All right, we're going to go ahead and do our last key video of going over last week's simulations, and we'll go over this warm-up. So in our first problem, we're talking about this particular officer who got $1,000 when he got off of his shift in tickets. He should be looking at about 8 drivers, or stopping about 8 drivers to get tickets. All right. So then we have this situation where we've got these rates associated with these fines right here. Okay. So because of these rates that need to be accurate to the ones place, 17, 8, 5%, then I'm going to be using 2-digit numbers. So my 2-digit numbers are representing the speeders that are detected. Okay. Now what happens is, I know we're looking at the 8 drivers that Officer Teague stops. So these digits 0, 1 to 70 are going to be ignored, because they are not going to be some of the 8 that he stopped. Okay. Now, if we had a question that said, how many cars is he going to scan to get those 8, then we would go through a series where we would be using the 0, 1 to 70, but that's not what this asked. Estimate the average amount of money that they take in for 8 vehicles that are stopped in a shift. Okay, so then I did these 17 were the ones that are fined $185. These 8 items are the ones that are fined $205, and these 5 items are the ones that are fined $300. So I used a random number table, start at the left-hand top left, and what's going to happen is I've got this trial, and it is consisting of 8 traffic stops. So I'm just going to look at those 8 stopped people. I'm ignoring the others. 8 stopped people, 8 stopped people. Repeats are okay because each car is independent of each other. And again, what do you ignore? I'm ignoring those digits that are 0, 1 to 70, because those people do not get stopped. Okay? They are not stopped. All right, so then when we look at that, our goal is to see what response, or on average, how many fines are assessed. So I'm going to get the sum of fines that were taken in during that shift of 8 cars stopped. I'm going to do this was the second amount of money taken in that 8-car shift. So let's look at how I did this on my my random number digits. So I kind of wrote up here again that I'm ignoring the numbers 0, 1 to 70, and so I'm dealing with these particular items right here. Okay, so here I went through this. The first person was a 78, so that was $185. This next one was a 0 to 1 to 70. This was a number 1 to 70. So see, I was crossing those out and ignoring them. So then 75 is then a person who falls into that category of 185. So see, each time I come across a person who gets stopped, then I'm marking down and I'm recording what fine they were associated with. Okay, so I go through here and I'm going through until I find 8 cars who got fined. So once I come across 8 cars who got fined, then that's the end of that shift. Okay, so a trial consists of detecting 8 speeders and then stopping. And then I'm marking. So my response is the sum that was achieved from those 8 fined cars. Okay? And so I wrote that sum down here. So let's look at how I worded that. So a trial consists of those 8 traffic stops, and that response is the fines assessed during those 8 during that entire 8-car shift. Okay, so I was asked to just do 3 trials, and so then as I went through, again, each time I was notating, how much fine was assessed per car that was stopped, and once I got 8 cars, then I summed up that value. So here are 3 shifts and the sum of the fines that were assessed. That gave me an average of 1,642. Okay, so the statistics, so according to my simulation, I expect the officer to assess about 1,642 fines on average in a shift of 8 stops. Okay, now, just FYI, I went ahead and I kind of just looked at theoretically what would this be, and so theoretically, what I did was I went into my one variable stats and I did this. I did these fines with this frequency. So I did one variable stats of this times each one of these frequencies, and I got, I think, maybe 205. I think it comes out down here. 209.50. And so then when if you multiply that by 8, you would get that 1676, which is pretty close to what I got with my simulation. So now, over here, let's go ahead and take a look. So I explained to you how to do this next problem, to go ahead and go back and practice this one variable stats. I said only do this for the drivers that get stopped, and I did mark that on your paper. I gave a note. Do not use this here when computing the fines, because those people were not fined or stopped. And so then we come on down here, and the standard deviation was the 41.36. So what's the probability of having that shift of 8 cars where the sum was 1,000 or less? And so I told you that's an average of 125 per car. So the officer had gotten on average 125 per car. Okay, and so what was that? What did that come out to be? All right, and so then here we have our z-score that was over 2 standard deviations. So since that $1,000 shift was more than 2 standard deviations below the average expected amount for a shift of the 8 stopped cars, it seems as though Officer Teague is wasting his time on this shift, because he should have gotten closer to the expected sum of 1676. All right, now, just FYI, a couple of my thoughts that I was wondering about is I'm wondering, and this is my inexperience, because I added this problem in here, wondering if that because these were for averages of samples of size 8, that technically, should I not have done this over the square root of 8? And of course, these are t-scores, because we're talking means. Well, if that's the case, then we could look and see, really, that would be a whole heck of a lot more standard deviations. I mean, a lot. In fact, if I went ahead and I computed that real quick, then I would have gotten that 125 minus 209.5. And then if I'm dividing it by that 41.36 over the square root of 8, okay, then that is almost 6 standard deviations below the mean. And if that's the case, then it's extremely evident that Officer Teague should be bringing in more. So, I think that this is probably where we need to be going, because this is the standard deviation based off of stops samples of size 8. And so remember, then that's our standard deviation. That is this here based on the samples of size 8. So at any rate, we do have that happening where it's out of whack. Okie dokie. So there's your warm up for Chapter 11 simulations. And so then you will be taking a quiz based on that.